Hi, good afternoon, everyone. I guess we'll get started. My name is Derek Tumulak, and today we're going to talk about transparent data encryption for Couchbase. Hope you've all had a chance to enjoy San Francisco in particular. Those of you that are not from the area, it's been pretty nice weather through the weekend and of course today. So hopefully you get a chance to make it outside. So Vormetric is a data security company, and so what we're going to talk about are solutions and some of the needs around securing data at rest. And so a lot of the emphasis here is really transparent data encryption down at the block or file system level. And we're going to go over a little bit further in the presentation how that's done. But earlier on, we're also going to talk about some of the needs and why we're seeing some of this demand and the need for securing information in this manner. So the high-level point here is really sensitive information is at risk. So as we've moved into some of these new environments, whether it's big data environments, cloud environments, even mobile, information is moving around. And so there's some interesting information here in terms of how organizations rarely detect or block access. So I won't take you through every single point here, but as an example, the one on the top right, very few actually block privileged user access. So how do you handle, for example, administrators, whether it's at the database level or at the operating system level? They ultimately, in many environments today, have access to the sensitive information that's held within your organization. So how do you block that access? How do you monitor that access? These are some of the considerations and the challenges that IT organizations face today. By the way, if there are any questions along the way, certainly feel free to ask. We can keep it pretty interactive. So really here, this is just an illustration of, again, why is there so much importance around protecting data, particularly, again, for the topic of this discussion, really the encryption of data at rest. A lot of breaches have occurred, everything from, your top retailers to government employees, stealing information they should not have access to. So for your organizations and the IT departments you work with, how can you put together those controls to make sure that only the intended, not just users, but processes or applications can actually grab that data and perform the necessary tasks with that information? Otherwise, if you have, for example, malware that can come into your organization, escalate privileges, and ultimately do something malicious with that data, that's obviously not going to be a good end result for your organizations. So, with all of that being said, the problem doesn't get easier. In fact, it's becoming more challenging. Traditionally, you had all of your information in your data center. You had a nicely defined perimeter. But now what's happening is the data is proliferating. It's moving outside of your corporate boundaries. It's moving into the cloud. That's probably the most obvious one as you adopt these different cloud services, everything from infrastructure to PaaS to software as a service type of solutions, all the way through to mobile devices, right? So these, the latest iPhones and Android devices can hold a ridiculous amount of information, especially by the standards of 10 years ago. And what happens if a consultant enters your organization, copies information onto that mobile device and leaves? All the way through to big data environments where you're consolidating a massive amount of information, which could pose a significant threat to your organization if that data was abused in some form or another. So this slide here really captures the importance of encryption again around achieving compliance. And what we're doing is we're seeing encryption adoption grow over time. And what's most interesting is that the majority of enterprises and organizations that are out there actually have invested or adopted multiple encryption vendors. And so the challenge with that is if you're implementing a solution for this database server, a solution for the following file servers, a different solution for mobile devices, it becomes very challenging to manage all of that. And so the key point is there a way to better manage all of that through more of a centralized platform? So one thing to look at is, so Vormetric provides the Vormetric data security platform. And so not just for big data environments, but for really multiple storage locations across your organization. So for example, if you have data sources coming in from third-party partners, or if they exist in a different database, and then ultimately if you're sending log information over to some kind of security intelligence solution you have, all of this is potentially sensitive information. And so what Vormetric is really capable of doing is providing protection. When I say protection, one aspect of that is encryption. But protection solutions from data sources through to information in Couchbase all the way through to the places that you're sending sensitive log information as an example. And I did say protection and encryption. I use the term somewhat synonymously. There's more to protection than just encryption. A lot of people equate encryption to, the way I think of it is full disk encryption, where you're protecting the bits and the bytes that are on, for example, my laptop or on a disk, for example, a hard disk within a server. That's the lowest level of protection you can really provide. At the end of the day, that really protects against physical theft of media. But what it doesn't do is it doesn't give you protection against logical attacks. So if a root administrator comes along, Windows system admin, if somebody manages a hypervisor comes into play, you don't really have protection against those types of either processes or users within an organization because they do have privileges. So what you really need is you need that encryption that I mentioned earlier combined with access controls so that only the intended users or the authorized users can actually get access to that data. And then on top of that, you also want to be able to have a rich set of audit information. And arguably in a really sophisticated environment, I would call it almost adaptive policies, right? So that if there is a piece of malware running around your organization, maybe you want to tighten the screws a little bit and lock down your policies such that only the mission critical applications can actually perform their tasks, and maybe you don't allow certain users that are generating reports and so forth to actually access data. So again, it's more than just the disk encryption. It's really the encryption combined with sophisticated access policies with a rich set of audit information that goes along with that. So just very briefly here, a little bit more about Vormetric. We've been around for about 14 years, over 1,300 customers, 17 of the Fortune 25. Just a quick overview of some of the organizations. We do focus on very large enterprise organizations. It's not your SMBs. It's typically government agencies, large financial, retailers, healthcare organizations, a couple key OEM partners there. And we're very much focused on not just traditional infrastructure, but where the trends are taking us in terms of cloud as well as big data. This is kind of a high-level snapshot of our platform approach. I mentioned earlier that do you want to make an investment in an encryption vendor that does say an Oracle database, one that does MySQL, one that does so that's the traditional approach. Going forward, it's really more of how can I invest in one infrastructure that allows me to solve or provide security and compliance solutions for multiple use cases. So again, if I've got my structured databases, I've got Couchbase in here. If I've got unstructured files living in, you name it, SharePoint or other types of unstructured environments. If I've got custom applications that are writing, say, PCI or HIPPA high-tech information into, again, databases, how do I secure that type of information? So it's really being able to invest in a single platform infrastructure and provide data security across multiple use cases. So I mentioned this earlier, we're very focused on cloud. Just a list of some of the partners here. I won't spend a lot of time on this, but very focused on that. And then similarly on big data, looking at some of the plans around big data going forward, who's investing in the technology, their timing. So clearly it's already happening today, and there's more attention and more investment being made in these areas. So with that, what I'm going to do is drop a little bit down a layer. So I don't have a demo at the moment, but at least I can drop into some more of the technology and show you some of the more specific capabilities around how we can protect information at rest. So the Vormetric solution itself consists of two high-level parts. One is the Vormetric Data Security Manager, which is a virtual or physical appliance that deploys onto your network infrastructure. So it could be a VMware appliance, or it could be a physical rack-mountable server that just drops into your data center. Think of that as the brains of the solution. It's where we drive the key and policy management. And the other part of the solution is what we call our agents. And these are software agents that deploy onto your database servers, your file servers. We provide support for a comprehensive set of operating system platforms, so Linux and Windows, and in fact, from previous years, also Unix platforms as well. So if you've got a large enterprise environment and you want to protect and provide controls for who can access what data across a wide range of environments, that's the intent of these agents. So the brains of the solution is that data security manager I mentioned right here, and then we can provide controls into each of the environments down further up here. Just a quick comment on high availability, pretty much a given, but the idea is the data security manager holds the keys to the kingdom, so to speak. And I know that with Couchbase, for example, there's the ability to provide encryption capabilities through a keyring type of capability. The Data Security Manager is an extremely highly secure environment. This appliance here, particularly if you go for the hardware variant, is FIPS 140-2 level 3. And so, if someone were to try to physically break into this device and steal keys, it would actually zeroize itself. So there's a very high level of security built into this. And so the idea is that if, say, a pair of them or a cluster of them are available on a network, if one of them were unavailable, in this case, the Couchbase server could go and communicate with a secondary device and grab its keys and policy from that device as required. So that redundancy is obviously very important, and obviously built into most systems today. But when you think about it from a security standpoint, you want to balance that appropriately. Okay. So so this here in this example is not intended to be KMIP. You can do we do support KMIP, and you can do the exact same thing. The difference is that here, this is Vormetric transparent encryption, which is the encryption solution we're referring to. If you had your own custom-built application or a KMIP client, for example, talking to our servers, these are KMIP servers, actually. So you can actually achieve the same level of redundancy by communicating with us through KMIP. So this is the main product we're referring to, and we've done a fair amount of testing here already and with Couchbase. And so where we plug in is really at the file system level. So we are a kernel module that basically sits on top of the native operating system file system. And so we intercept calls. So if you're reading and writing, we transparently encrypt or decrypt information as blocks of data are written and read ultimately from disk or from storage. And so that's where the magic occurs. Now, as I mentioned earlier, it's really tied to policy as well. So we overlay with existing users and groups. So whether it's LDAP or Active Directory on Windows, we can identify who has access to what information. And then, of course, as I mentioned earlier, we provide a very rich set of audit information. So everything really gets captured here. The policy is taken from the Data Security Manager. And not only that, but the data in terms of who's accessing data, under what circumstances, at what time, who's trying to access data but getting access denied. A great example is if you see somebody repeatedly trying to access data, but their access is denied. Or another common one is if suddenly someone's accessing data at very odd times, that information, that audit information, is captured and sent to, through reports to a number of SIMs that we support. And you can actually, basically throw up a red flag or at least a yellow flag saying, hey, somebody should take a look at this. Something anomalous is happening within your organization. Right, so I have a slide later that talks about some of the policies. You can define policy either at the group or the individual user level. So it's either, it's not necessarily one or the other.
Okay, so you can't have a group and then subset of that as a user giving certain privileges.
You can have multiple. So you can have group-based and user-based policy, and it's evaluated almost like a firewall set of rules. So it just evaluates down. Yes, exactly. So I'll have a slide, I forget exactly where, it's probably in the next 2 or 3 slides that illustrates some of that. And you can see the evaluation process in terms of whether or not you can gain access to the data.
One question, how does has impact, because you're doing encryption, decryption, right?
Right.
How does it impact my existing performance?
Performance? No, that's a great question. So there is an impact because you're actually transforming the data. You're converting it from plain text to ciphertext on the way down, and then from ciphertext back up into plain text on the way out. So we do take advantage of, for example, if you're running on Intel platforms, which you mostly are, we'll take advantage of ASNI. So that's the crypto acceleration hardware offered by Intel. We've also done a lot of optimizations on our own as well. So if you put us head to head with almost any other solution out there, pretty much any, we'll actually outperform them. What does really matter and come into play is the type of workload that you're running. So I'll give you an example. If you're operating, so we are at rest encryption. That's the main focus. So if you are running a transactional environment and you're hitting a cache that lives in memory predominantly, then there's pretty much zero impact because you're never hitting disk. There's no I/O on disk. On the other hand, if your workload is very disk I/O intensive, particularly small I/O, right? That's where we do tend to see more of a performance hit. So, the saying your mileage does vary to some degree. That being said, we've optimized the performance considerably across a wide range of big data environments, as well as some of the legacy environments we've deployed in as well.
So would you have some numbers for Hadoop? Because that's primarily the disk-hitting I/O activity. What's the rough impact? Is it like 3 to 5% or more than that?
So again, it does depend on the workload. I have some information. We do have a white paper, or a couple white papers actually, for some of the different big data environments. If you want to send me a message, I can give you some of the specifics on that. But it does vary from one type of workload to another.
I have one follow-up question. I mean, it's a generic question, not related to Couchbase, because I don't know what is the encryption security natively implemented by Couchbase. But there are, for other database, like Oracle or some other database,
Yes.
They have their own solution for encryption, right?
Correct.
So, if I do have environment where database native solution has been implemented and I want to bring this volumetric security, how, whether I could change that or
Yeah.
rely on this or
That's a great question. So from our perspective, there's two high-level approaches. One is you can replace the existing one with our solution. So if you use Oracle as an example, they have a field-level approach. They have more of a table space approach, both of which will outperform. And on top of that, they all are restricted to information in the database itself. So if you have log files outside the database, other types of unstructured data as an example, or even other databases, that's not something Oracle would do. So that's option number one is replace the existing Oracle solution with something that is managed centrally, a single solution that can address your, from an enterprise standpoint, your heterogeneous environment. That's obviously our preferred approach. The other approach is touching upon KMIP, but not today KMIP. There's Oracle and other organizations support a capability called transparent data encryption, and they provide the ability to point to external key management. So you saw the slide earlier. Actually, the data security manager is essentially it's a key manager. Some of you might think of it as a network HSM, but it's got a high level of security. And with that capability, if you have, you name it, an external database that can defer to a centralized key manager with a high level of security, we have that capability, Oracle being one of them. So at the very least, why keep your keys on the Oracle database when you can actually have them live on a separate trusted appliance?
So looks like it provides encryption at a file level.
Correct.
So is it like all or nothing encryption for, like, let's say Couchbase, right? It has its own data store and it's stored in a file. You can encrypt the whole file, or is it at more like field level or within the Couchbase?
That's a great question. So for the product named Vormetric Transparent Encryption, it's at the block level and it's the entire file. So there's less granularity there. In the next slide, actually, I'm going to talk about more of a field level approach. But this product here is primarily focused at that file level type of solution, encrypting blocks of data. So that's exactly how it works.
And then the other part is the user. So let's say like Couchbase is running inside the system as like Couchbase user.
Yes.
So would that be the user, or is that the user who's accessing the...
Right. So we have no awareness of the Couchbase user. We're only aware of the operating system user, so who Couchbase is running as, different processes, tools, for example. So, I know that there's a tools directory, for example. What we can do is limit who can actually access the data. So read the data from disk, for example, which processes as well. So if there's a certain set of tools, and we actually, those tools are hashed and signed to make sure they're not tampered with. So we have security capabilities to ensure that only the appropriate applications/processes and users can ultimately access data. So that's the level we operate at. Once you're in the database, as a Couchbase DBA, for example, we don't see that through this product.
But you do see as an individual user going in and the Couchbase database and then accordingly have access to different buckets or not?
We don't, no, we wouldn't see that. Because we're at the operating system block level. Exactly. So that's how Vormetric transparent encryption works. It's really at that lowest level. The wonderful thing about it, the word transparent, right? It really requires no application changes. You drop it in. In fact, we have this amazing capability called learn mode, which lets you simulate what would have happened. So we create all these rich reports, and basically it lets you identify two things really well: is people that are doing things they shouldn't have been doing, because we don't want to disrupt anything when you're just initially deploying, right? Why block access? And it also lets you identify where maybe you should be giving people access to certain data, but that wasn't originally part of the policy. So it's really helpful in calibrating your systems initially, rather than turning everything on and creating a lot of angst, right, or grief in the first month of deployment. You can run it in learn mode, and then based on that, adapt your policy or change other things within the organization to match your true security policies.
So one more question. So DSM seems to be the main point to be contacted by every user if they deploy that.
Correct.
Do you have some numbers, how many users it can handle, and how do we grow that?
Yeah, absolutely. So our largest deployment, so it's not so much users, it's more servers. So ratio of servers to DSMs. And so our largest deployment is north of 15,000 servers. These are physical servers. We've seen a lot of activity in cloud environments as well because of the bursty nature and so forth. But we actually have a customer, very, very large customer, obviously, with more than 15,000 physical server deployments. And they have, I think, approximately 8 DSMs managing all of that. And so the reason we're able to do that is that there's not a lot of chattiness here. I mean, basically, a system comes up, grabs its keys and policy, and then unless you say it needs to refresh periodically, or if the system reboots, it really doesn't need to come back and talk to the DSM. So it's able to operate mostly autonomously, unless, of course, again, I mentioned a reboot or some kind of event occurs. The disaster scenario we need to worry about, of course, with those 8 data security managers I mentioned is, if you have all 15,000 servers suddenly reboot at one time, right? What's the load and all that? So that's what we need to be able to account for, which we have. So if that gives you a sense, we generally say, it depends again on the type of workload, but about 2,000 servers or agents communicating to a DSM seems to be the right ratio.
Does that mean that the keys are stored in clear in memory while the operation is running?
So the keys are secured here, and they are securely, very elaborate security model to transfer the keys over here down into kernel memory where the keys are also secured. So they're obfuscated and protected with other keys in memory, but they're never exposed in the clear, so to speak. I mean, they obviously are used by the ASNI chipsets from Intel and so forth to actually perform the crypto operation because they have to get used somehow. But everything is done based on a security best practices approach.
Somebody uses GDB to attach to the memory, they won't have to receive it.
Right.
And is it a standard AES CBC or are you using something?
It is CBC, and then the last block, I forget, it just eludes me right now, but the last block we use the different one to make, so we don't have to do a 16-byte boundaries.
Can you repeat that question?
The very last one? So if it's standard CBC, AES CBC, and so we do AES CBC for all 16-byte blocks, which is what a AES cipher is. But then the last block, because what we do is we actually maintain, it's transparent encryption, so we actually maintain the same file size. And so I forget which mode we use for the last one, but we're able, instead of going on a 16-block boundary, we're able to match it exactly. And again, it just eludes me right now which one that is. Somebody in the room probably knows, but